Hey Cassidy, so for this one, the 80, the biggest perfect square I can get out of that would be a 16 times a 5. So that's going to let me take the 16 out in a second. A couple of ways of thinking of this x to the 12th. I'm trying to figure out how many pairs there are, or if I can write it as a squared. Anytime I have the square root of some math, whatever that math is, squared, it's just going to be the math. So whatever this chunk of stuff is that's squared, that's what will come out. So if I think of this as a squared, I can think of it as I have 2x to the 6 y. So that's one way of looking at it. Then when I do my root, square root of 16 would make a 4. Square root of 5, that stays in. The square root of x to the 6th squared would bring out x to the 6th. And then I can't take a square root of y because I need at least a pair, so the y would stay in. So that's one way of thinking of it. For me, this is kind of how the books show it. I actually kind of hate that. I think of you'll see in future classes, there's cube roots, fourth roots, etc. I just envision the invisible 2 here, and I just go 2 goes into 12 6 times, and that's how many are going to come out. Because when I go 2 into 12, what I'm really doing is I'm counting how many pairs of 2 there are. There's 6. So it works pretty good if I had the square root of x to the 5th, y to the 10th, z to the whatever, 4th. That would be 2 goes into 5, 2 x's come out, 1 would be left. 2 goes into 10 5 times, so 5 come out, none left over because there's 2 sets of 5 in there. And then 2 goes into 4 2 times with nothing left. So the division idea works pretty easy once you get a handle on it.